A quick discussion on the laboratory grid mill um, and the different types of recovery methods that we're going to be using or trying out to see the best suited way to recover our precious metals after it's gone through this lab mill. Um, so initially you put all your material into this hopper right here, and then it goes down into the pendulum feeder and then down into the actual ball mill itself. The ball mill rotates, everything gets ground down, comes out of this chute right here into this regrind spiral classifier, which then transports the oversized material up into this worm drive right here, and then the worm drive delivers it back into the ball mill for regrind. And then the material that gets ground down, once it hits a specific size, kind of floats up into this trough. See how fine this material is. Comes down and then into the sluice box. The material that we ran yesterday, showed some gold, some silver. We're not sure. I'm not too sure what the grade of that material is, to be honest. It was a friend of mine's stuff. This is the material here. It's a lot of brecciated quartz. It's from a known gold area. From what I saw, just in the test pans from the concentrates, it showed some silver, possibly some rhodium. But what we're thinking is we're thinking about using the spiral column in lieu of the sluice, and to see if we can get a better concentrate out of the lab grid ball mill. When you buy this unit, it does come typically with 3-phase motors. It's got the start off box that's 3-phase, so you need 3-phase power for it. When I got this unit, the motors were missing, and so I had to Frankenstein it. Obviously, we're not using the box because it's set up for 3-phase and I'm running single phase. And so for the pendulum feeder, I pulled a motor off an old drill press. It's a 3rd horsepower. Another 3rd horsepower off a drill press for the spiral classifier. I got a 2-horse motor here for the actual ball mill itself, which I might take that up a notch and go to a 3-horse. And then I got a 1/4 horse for the return auger. Only issue I have is this Lovejoy connection. This was on the gearbox, but because I had no motor, I didn't have the other side of this, and I cannot find these anywhere. I've looked at lovejoy.com. They don't have these, so I'm gonna have to get a hold of the manufacturer and see if I can have it shipped to me, so that way I can put in the proper Lovejoy connection fitting. I do have another coupling coming today that should work for the time being. The lab ball mill, here's the plate. It's a continuous ball mill. That's the model number. Feeding size that goes in the drum up here is 5 to 10 millimeter. It'll do approximately 45 to 90 kilograms per hour, which is between 100 and 200 pounds per hour. Output size is 0.074 millimeter. That's pretty small. It's in the micron level, sub-micron level. So far what I'm seeing is the grind size is really consistent using the return auger for the continuous feed. We're getting a consistent well liquefied slurry going down the sluice. It's got a good solid to water ratio. It's probably running close to I'd say 15 to 20% solids to liquid. And then from there it goes down to this dewatering screen, which dewaters the tailings into a bucket. This is a 200 mesh screen. But I am noticing that because of the ball mill, we're getting a lot of minus 200 mesh into the water containment system, which will be problematic later on. What I'm thinking about doing is putting in a bulkhead fitting and then running or pumping that water out of there in through a sand filter, and then that'll go to a drum. The pump would be here to feed the system, and then we would backwash that that filter into a container to put through the column for later on when we want to recover the ultra fine minus 400 mesh gold and silver and whatever metals we have. Yesterday was the first really good test run of the complete system setup. Like I said, that one coupling is the only problem issue so far. I do have a spare star for it, so I'll have to replace that probably today because the rubber is starting to break loose. To be expected, it's not the proper Lovejoy fitting. Like I said, this is the one that came with it, and it should look like this, but this size. So it's pretty significant size difference. But other than that, works really well. Material that builds up gets collected in here, and then you can hose it out. And then for the return drum, as it goes through and gets brought into the actual ball mill, there's a containment system right there for the heavier, bigger particles. Before I had the sand screw and all that set up, we were getting a lot of coarse gold in that. Yesterday I didn't really see a whole lot, but also I don't know what that material really holds, to be honest. So it is what it is. Yes, I know I don't have a belt guard. This belt doesn't really move all that fast. The way I have it ratioed, it's just enough to move the material up and back into the ball mill. The sluice box is kind of one of my major concerns, and that's just because I don't know if that's going to retain the gold or gold and silver from the particular size that we're grinding down to. And I'm thinking that we might have to replace this with the spiral column concentrator, and or goes direct to a table. My thought is probably going to the column here. We'll have it pumped up in. This only runs at about 5.5 gallons per minute of water and slurry. Slurry content should be about 15% solids to 85% water, but it's a really slow going process as far as like the water distribution, but it does concentrate really well. And I'm thinking that the tailings from this would go to the sluice, and then the concentrates would go across the table. And I think that might be the best option. Now, manufacturer wise, this is supposed to do 200 pounds an hour at the 5mm range. I haven't timed it yet to really see if that's the correct throughput. I got the stuff that I'm testing today is from Nevada, so I know it's got a high silver content and some gold in it. I got about 150 pounds worth, so I'm going to time to see how long it takes to go through the system. One thing I did notice yesterday when I was running Brian's stuff was this return auger, this spiral classifier, likes to have a consistent feed of material coming in order for it to work properly to suspend the material up and out. And once it starts towards the end of the day, when we're getting through the material, we did notice the material wasn't lifting up and out, and that had to do with the lack of material in the actual spiral classifier here. And so that's something that we're going to have to kind of figure out the proper usage of this, as far as how much material needs to be in here before we just clean it out. Because we're two different mines are running this, it's got to be cleaned out after each use so that we don't contaminate one person's concentrates to the other. Brian's material is coming from down south and like the southern area of California. My material is coming from a different mine, a whole different region of Southern California. Different types of gold, different types of ore. His area is known for rhodium, gold, silver, and some platinum groups. My area is known for just gold and silver, rubidium, and hafnium, and a lot of zirconium. And so the difference in ore is quite significant. And then the material that we have coming from Nevada is primarily silver with some gold on the tail end. And so when we run the material through, depending on where the material is they're from, that'll determine the values. But like I said, because we got two people running the machine at different times from different areas, a complete clean out of the system needs to be done after each run. Luckily, we're not running a huge amount of material. My big equipment is in storage right now. And the reason why we set up this small 1-ton system is two reasons. One, space. I don't have the space to put my big equipment at the area that I'm at right now. Two, I want to dial in the recovery based off this system so that when I do set up my large equipment, I can scale it to the same setup style. And so right now what we do is we jaw crush through a 2x4-inch jaw crusher, and then we hammer mill it with a 3/8 or a 5/16 inch screen, which takes it down to the size of the material that you've seen in that bucket, and then it goes through the ball mill. When I set up the large equipment, it'll go from the big jaw crusher that does 10 to 15 tons an hour through a hammer mill that does between 2 and 5 tons an hour. And then from there, it's going to go into a large ball mill similar to this with the same features. It's going to have a regrind circuit. And so once we get this narrowed down and we get the recovery method dialed in 100% to where we're retaining at least 90% of the metals going through, then we can focus later on the big equipment to set it up exactly how we have this small system so that we can recover as much material and metals as possible without having the significant losses. Um, and throughout all the years of my mining, I placer mined for a long time. I was dredging, and then when they banned dredging in California, I kind of refocused into hard rock gold or lode gold, and that's been a learning curve in its own for the last so many years. Let's see, my oldest daughter is turning 21 next month, so I've been hard rock mining for right around 17 years, and it's been a huge learning curve. I started out with a 2x4 jaw crusher and a flail mill or a chain mill with a small RP4 shaker table. It's a 2 foot by 4 foot. Didn't really know how to smelt or recover that real fine gold, and then as we learned through the next year or two, I learned how to smelt, learned the different fluxes, scaled up to a larger jaw crusher and a hammer mill, and then I had a large column like this and a big 15-foot table, and we did okay running it that way, but I feel we were losing a lot for as much as we were gathering. And so when I set up the large equipment this last time to ramp up the tonnage, I ordered 2 of these columns, but they were the 4 foot diameter by 20 foot tall, and 2 6 foot by 15 foot shaker tables. Everything was going somewhat okay. We had a lot of losses. And so there was a few things that, looking back at my setup, I should have changed or I should have added to the circuit. Primarily, one of the things I should have added was right after the hammer mill, I should have had a sluice box separating and concentrating material coming off the conveyor, and then having that material go to a ball mill and then to an agitation tank and being pumped up to the columns and then to the tables. That's how I should have had that set up. Knowing what I know now, based off all the different types of recovery, I think that's going to be the best bet, really, is going from your primary to your secondary to your mill. And then from there, it's going to get reground, and that material is going to go to either the sluice box, then the column, or vice versa. Column, then sluice box. And then all the concentrates will then be tabled to separate the gold, silver, and possibly platinum groups, depending on the material that we're running. Today we're going to be running material from Nevada, and then we're going to go from there. We'll make the changes that we need to make this week. Possibly introduce this into the circuit. I've got to build a stand for it. I'm going to have to get another pump to pump up into that, and then go from there. And so the power is an issue right now because everything's not running through that control panel. I have to run it off a generator, and the generator, because it only has one circuit on it, I can't plug the whole system into that because it pops the breaker. And so I can run 2 things off the generator: the vibratory, the dewatering screen, the pump, and the pendulum feeder gets ran off the power from the building, and then the other spiral classifier that gets run directly off the power from my house. And so, it's kind of a long run, but it got us going. And so we're going to have to kind of rethink the power situation, because obviously you can't run I tried plugging in just the 2 auto feeders, the spiral classifier and the worm drive into the generator, and it popped that breaker, because it's even though it's got 2 outlets, supposedly both 20 amp, they're still on 1 breaker, and so that didn't work out too well, and so I'm gonna have to kind of rethink the power situation there. Right now we're focusing on recovery. Now that everything's running, now we got to figure out the best means of recovery, whether it's going to be going through this column or going through the sluice and then the column, and then we'll go from there. So it's just a quick rundown of the Lab Grid ball mill. I'll do some videos of it running because I don't see a lot of videos of this particular ball mill on YouTube. Now I do see it being ran before being shipped, but I don't actually see any videos on YouTube of this particular style of ball mill being actually used in an everyday situation. And so that a lot of the reason for this video is to, one, introduce you to the Lab Grid ball mill, kind of go over the things I've noticed, and then go from there. And then I'll do some videos of it actually running, and then the progression of the recovery system as we kind of adjust to the mill. And then once the final setup of recovery is done, I'll do a real nice video of everything being ran, and then I'll do some YouTube videos on that, and then hopefully we can get this shared out there, and people can actually see what the Lab Grid ball mill is actually capable of, the real throughput of ore, of how much ore can go through in an hour, not just what the tag says, the actual reality of it, because everything if they say it's 2 tons an hour, it's probably a ton. If they say it's a ton, it's probably a half ton. 200 pounds an hour is what this says. Realistically, it's probably 100 pounds. And so I'll do some timing today. I'll time the 160 pounds that I have, see how long it takes to go through, and then I can base that the time throughput off that. So, and that's pretty much it. Hope you guys have a good day, and